Hey, how's it going? It's Kyle, and I'm back to talk about part 4 of our homework, in which we will vectorize the function we made in part 3. To remind you, the function we made in part 3 is what's calculating the x, y, and z values of the circle we want to put around each point of our line to begin graphing our pipe around our helix. This part is where we vectorize the function we made, which will actually let us plot our pipe. So to do this, we'll be using a numpy function, well, a jax.numpy function called vectorize, in which we can feed it a function, and it adds a dimension to our function, basically repeating our values of our function along as far as we want. So we'll get into that. So first I'll just define a variable, and this is actually going to be a function itself. And as I said, we'll be using vectorize, so jnp.vectorize, and we want to give it the function we want to vectorize, so it's our surf function, and then we need to add in the signature, in which we tell it that we're feeding it a scalar, and add in an array size 3. So now we have the surf vec function. So what I want to feed it is not only our t values but also the theta values. And I have t and theta defined up above. So t is the length of our helix. So it's from 0 to 4 pi, so 2 times around, and we're just doing 36 values of t evenly spaced. And then theta is what we use to create the circles around each point of our helix, so that's from 0 to 2 pi, since it's just a circle, and we're doing 18 different theta values. So if we run this, it won't work because we need to add a dimension to both t and theta. So for t, we want to keep all our t values, so we want to do keep all our values, and we're just adding the blank dimension here. And theta, we're just doing the same thing, but we want to add the blank dimension first. And then keep all our values. So now this should work. Oh, I do not need this comment here. Alright, so let's take a look at just the shape of this. So right now it's a 36 by 18 by 3. So we have, for each t value, we have 18 different theta values, and then for each t and theta value, we have 3 different values, and that's just the point, our x, y, and z values. So now this is a good thing. Minor problem here is we have our x, y, and z values out here in this third dimension where we want to flip this array so we can pull them out first. So to do this, I'll just make this a variable. We'll call it s1, just make it easier to mess around with. And all that's doing is just storing our surf vec function as s1. So if I take a look at s1.shape, I'll actually need to get rid of this shape first. It's just the same thing. So now to flip around this, we can take a look at using the transpose function. So now, if we look at the shape now, it's 3, 18, and 36. And same thing, I'll get rid of this shape, so we're actually making the function, or making the variable. I'll call this one s2. So now we're able to actually pull out our x, y, and z values from s2. So if we say x, comma y, comma z equals s2. We now have two two-dimensional arrays, so if we just want to take a look at x, we'll take a look at the shape first. So we can see that x is a 2D array, and it's 18 by 36. So this is basically, it's all the x values we have, and it's all the x values at each t value and at each theta value. So we can run through and we'll be able to plot this as our x values in our 3D plot. And then y and z are the same thing, so if I take a look at y, it's just the same thing, but it's our y values of this the circle we'll be plotting. So I don't need that anymore. So now we have all the values we want to plot, we just have to actually do the plotting. So copy and paste this up here. I don't need to use our curve function because that's just our helix, which we don't really need anymore. We're just doing the pipe around it. But we'll get into it. So since we want to plot each value, we're going to need to run through and use a for loop. So for I in range, and we'll start with our theta, so we'll plot like the actual lines. So theta.size, and this will be plotting our points at each theta value that we have. So for I in range of theta.size, we want to add our x, y, and z values. So add scatter 3D and x. As I did up here, we have our arrays of x, y, and z values, so I just need to do x, and we want all of our x values for each theta. We want y, all of our y values for each theta. And then z, we want all of our z values. I think I might have flipped these actually. And then same thing for z. Load lines. And here we go. So now we've plotted the actual lines around our central helix, as we can see. But we want to kind of make it look a little neater, so we want to graph the circles at each t along the helix. So all we can do with that. Oh, and also real quick, I don't like how there's so many different colors popping on here, so we're just going to make all the lines the same color. And we'll say white. So now if we rerun and see, we have just one solid color. So to graph the circles, we just do the same thing. So we need another for loop, and we'll just be plotting the x, y, and z values. This time I'm going to do the size of t. And we want to just reverse everything we have here. So for each t, plot all the x's. For each t, we'll plot all the y's. And for each t, we'll plot all the z's. And same thing, we'll keep the line color white, mode lines, and if we take a look at it, we now have our pipe, and it's going a radius of 0.5 around our central helix that we made in the earlier parts. And let's see, I think, yep, that's what we're going to do in part 4. So yeah, here it is. You can take a look at it. It goes around 2 times. And it looks a little choppy, and that's just because we only did 36 points for t and only 18 points around for theta. So if we wanted to get into make it like looking like a smoother pipe, we could just increase the number of t points we have. And same thing if we wanted more lines around the outside, we could increase our theta values, because right now we'll have 18 of these lines around the outside. But it just kind of keeps it simple with only 36 and 18, so the runs don't take too long. But there we go.